Hey, hello Alg II students. Today we're looking at 11.1, 11.2, day 1. We're going to be looking at some angles and trig functions. I got 15-minute limit on this video. I'm going to do my best to try and get that video done in that time, but I don't want to rush too much. We may end up with 2 videos on this, but here we go. So the first couple slides, we're just going to be reviewing the Pythagorean theorem. When we get into the trig functions and angles using that, there's going to be situations where you may have to find the third side of a triangle. So this should be a review. If we recall the Pythagorean theorem, is that a squared plus b squared equals c squared, right? Where that a and that b are your legs, and that c is your hypotenuse, which is the longest side of the triangle, or the side opposite the right angle, right? So it doesn't matter which leg you call A or which leg you call B. You're just squaring both those legs and you're adding them up. Now, when you're missing a hypotenuse like we are here, okay, we are missing our C value. So in order to solve, we're going to take your two legs. Again, it doesn't matter which one is A, which one is B. So we're going to say that 20 squared plus 15 squared has to be equal to C squared. And we spent a little time solving for variables with exponents before. Now, order of operations, something needs to get taken care of here simplifying wise before we can start actually solving in terms of the equation. 20 squared is going to be 400. 15 squared is going to be 225. And that's going to equal C squared. So then we add these two sides up. And 625 is equal to C squared. And then in case we've forgotten this next step, in order to get C alone, when it is currently being squared, to solve equations, we do that inverse operation. The inverse of squaring something is taking the square root. So we take the square root of both sides, cancels out the fact that C was being squared, and now C is all alone, and that left-hand side is going to be 25. The square root of 625 is 25. I know some of us, well, what about positive and negative 25? Yeah, well, technically you're right that both of those are an option, but we're talking about the side length here. You're not going to have a side of length negative 25. So when you're taking measurements, it's always just that positive value. Okay, so then there's that other option where we're missing a leg using the Pythagorean theorem. Okay, again, it does not matter which leg you call A, which leg you call B. Okay, when we end up with this equation, we've got A squared plus, we'll call that 11b, 11 squared, equals that hypotenuse of 17 squared. Okay, so this is the other option here, is when we're missing a leg, not a hypotenuse. So that A squared is what we're going to end up solving for. 11 squared is 121, and 17 squared is going to be 289. Okay, now to get that A alone, before we can take the square root of anything, we got to make sure that that A squared is all alone on one side before we can get it completely alone with the square root. So we're going to do the inverse and subtract 121 from both sides. Going to end up with A squared equaling 168. And then when I go ahead and take the square root of that, they want you to round your answer to the nearest hundredth, which is the second decimal place. Going to end up with a long decimal of 12.9614, blah, blah, blah. And we round it to the nearest hundredth. You're going to get 12.96. It does not have to round up because the 1 is in the thousandth place. Okay? So that's our little review on the Pythagorean theorem, which is going to come up in a few problems where you have to get all three sides in order to use them for your trig function. Now, on the notes that I have given, there's some of those Pythagorean triples. Okay? So those are some right triangles that we know what those three sides are going to be equal to. And 3, 4, 5 is that most prominent one that we see a lot. You have a 3, 4, 5 triangle. The longest side is always your hypotenuse, and then you've got a leg and a leg. Okay? And you can use these you see a triangle with a leg of 6, a leg of 8, you know the hypotenuse is 10. These are pretty much just multiples of the 3, 4, 5 triangle. Okay? And these are listed on those double-sided notes that I attached to the checklist. And then for those of you that are in class, you actually got this copy of notes, and these are listed on there. Okay? 10, 24, 26, and on and on and on. There's triples that we know as far as those whole numbers that come up pretty often. Now, you don't have to memorize those. They're just things that we kind of see commonly, and we can refer back to those known triples. Now, trigonometric functions. There's also a whole side of the notes that are dedicated to this. Okay? So on that one side of the notes, you'll notice those main functions that we're going to see are sine, cosine, and tangent. Okay? So the sine, and we're going to see that marked often as omega. Okay? Really just the sine of some angle. Sine is going to be opposite over hypotenuse. Now we'll talk about exactly how we're referring to those sides in a given triangle. It has to do with which angle you're focusing on, and the hypotenuse doesn't change. Opposite over hypotenuse. Cosine is adjacent over the hypotenuse. They're going to be fractions. Oops, I popped and I spelled that wrong. And your tangent is opposite over adjacent. Okay? So those are your three main functions that we have. The inverse of them, we've got cosecant. We've got secant. And we've got cotangent. Okay, now each one of these, you'll have this stuff on your calculator, which we'll get to in a minute. Okay, and you'll notice that cosecant is sine flipped, so it's hypotenuse over opposite. Secant is hypotenuse over adjacent, which is cosine flipped. And that cotangent is tangent flipped, which is adjacent over opposite. Now, you're not going to see these ones as often today. Okay, again, all this stuff is written down here. You don't need to necessarily memorize these right now. All 6 of them are written down here. All 6 of them are written down on your notes. But we have a way of memorizing these. And you've probably heard it before. Okay? Sine is the opposite over the hypotenuse. So cosine is adjacent over hypotenuse. You got the CAH for adjacent over hypotenuse. And then your tangent is opposite over adjacent, TOA, TOA. So, ka, TOA. That's that way that you're going to hear this referred to. You make sure that we have SOH for sine is opposite over hypotenuse, ka, cosine adjacent over hypotenuse, TOA, tangent opposite over adjacent. Okay? So we got kind of a little way of memorizing that. Again, for the foreseen future, you'll have this to look at, so you don't necessarily need to have them committed to memory, but this is how you will hear it referred to going forward, and it's a nice little way to remember that with those little acronyms for yourself. So when we use them, okay, you'll have some situations today where you're given all the sides of a triangle. And what you're going to be asked to find in this case are the three main functions, tangent, sine, and cosine of angle B. Okay? So depending on what angle we're talking about defines where the opposite and where the adjacent are. The hypotenuse is always that longest side across from the right angle. That's always the hypotenuse. Okay? Now, opposite and adjacent depend on which angle you're working with here. So since we're talking about B, okay, angle B, the opposite side to angle B is that side AC, the one with the length 24. And adjacent is whatever side, the other side that is coming off of the angle, which in this case would be CB. Okay, so we've got hypotenuse in blue, opposite in green, adjacent in purple. Okay, so on Alex, for these first ones, okay, they're just going to have tan of B to be an equal sign, and we're going to have all these fractions that we're giving off, because tangent, if we remember, TOA, is opposite over adjacent. So you're just looking at what those measures are. That's all you're doing here. So opposite is going to be 24 over the adjacent side, which we've identified off of angle B, is 7. And that's it. You're leaving it there. Okay? Sine of angle B. Sine, so, OH, is going to be that opposite over the hypotenuse. That opposite side from angle B is 24. And the hypotenuse, always in this triangle, that longest side, is 25. That one's done. And cosine of angle B, cos, angle over hypotenuse, excuse me, adjacent over hypotenuse, 7 over 25, and that one's done. And that's all you're worried about doing here for those problems where you're given all three sides. Okay? So now, when we're looking at a situation where you just have each side named not with the length as a number value, but each length is a variable, nothing changes. Okay? Don't be thrown off when we have variable situations. All you're doing is still paying attention to the SO, CA, TOA. We're looking at angle X, which they have marked, and adjacent and opposite will be based on where that angle is. Hypotenuse is always that longest side away from the right angle. Adjacent in this case is that side labeled D because it's the other side coming off of that angle we're focusing on. And opposite is that side, in this case the one labeled F, that is directly across from the angle in use. Once you have those three identified, as long as they have some form of measure, in this case it's just variables, you're ready to give your fractions for the sine, tangent, cosine. So again, sine is going to be SO, opposite over hypotenuse, which in this case, using your variables, opposite is F over the hypotenuse, which is E. So you're just filling that in as F over E. Tangent, TOA, opposite over adjacent. Opposite is that F. Adjacent is D. F over D. That's all that's happening here. And then cosine, CA, adjacent over hypotenuse is going to be the D, adjacent over the hypotenuse, in this case E. So it would be D over E, adjacent over hypotenuse, and that one is done. So I'm about out of time on this first video. We have 3 more examples that I will have another video of, where we actually have to find the third side before we worry about answering what question is asked.